Okay, so here is C-12, interpreting quantities within a derivative sequence. So remember that so we got to remember this. So this is a new fact. Remember that when you integrate a rate, you get the net change. When you integrate a rate, you get the net change. Okay, so net change, um, there's two ways that we can think of this. Lots of ways actually, but so integrate a rate. So if we do the integral from a to b of a rate, um, that is one way that you would get the net change. All right, and then another way is if you have like an initial amount of something, and then you have its amount. So if you have the amount of something at the beginning of a time interval, and then the amount of that same thing at the end of the time interval, if you take the final amount and subtract the initial amount, you will get the net change. Okay, so when you integrate a rate, you get the net change. And the net change theorem says, this is a fact that you can apply under certain circumstances, says that if you've got these three conditions, then we can do this. Okay, so if f of t equals a quantity at any time t, this function must be differentiable. So that's the first condition. Second condition, f prime of t is the rate of change of that quantity. And f prime of t must be continuous. And guys, these actually imply each other. So you don't really need to say both of these things because they do imply each other. And three, f of a is a known quantity. So actually, guys, instead of known quantity, let's say f of a equals initial and initial amount. Okay, so if you have those three conditions, then the net change theorem on the interval, the time interval AB, says f of b equals f of a plus the integral from a to b of f prime of t. Okay, and guys, I want to just like edit some of the language I'm using here. So f of b is the final amount. Oopsie, and f of a would be the initial amount, and then that's the net change. I'll say net change over time interval. Okay, so we're about to use this. So the rate in tons per hour at which gravel arrives at a construction site is modeled by g of t equals this, where t is measured in hours since 6 a.m. At 6 a.m., there are already 500 tons of gravel at the site. So guys, this here, at 6 a.m., there are already 500 tons of gravel at the site. This is an initial amount. Okay, so always be on the lookout for if they're giving you an initial amount of something. Okay, so find g of 5 and interpret it in context. Find g prime of 5, same, and then we'll take a closer look at c. Is modeled by this. All right, guys, this is a differentiable function, by the way. Cosine is differentiable. What's inside of it is differentiable. So this is a differentiable function. And I know I want to be thinking in terms of a derivative sequence because here, g prime. Also, this is a rate. So that's another indicator that we're dealing with a derivative sequence. Now, guys, when we're doing these context problems, I'm going to first set the sequence up like this, okay? And I'm I'm going to choose a letter that they are not using. Okay, so F is nice if they're not using it. So there's F. So the rate in tons per hour at which gravel arrives at a construction site is modeled by this. So G of T. Guys, where is G of T in this derivative sequence? Okay, it's actually right in the middle. So G of T is right in the middle of our derivative sequence. There's a lot of clues. The rate, that is one clue. Another clue is its units. Oh, it should be, actually. But they didn't give the units on this. But anyway, this would be tons. This is tons per hour. This one is tons per hour, but we could say tons per hour squared. And that means the same thing. Okay, so we set up our derivative sequence. So this is going to help us do the interpretation. So find G of 5 and interpret it in context. All right, guys, if you don't already, please get a calculator in front of you. Make sure you're in radians, and we're going to graph this. Okay, so 90 plus 45 cosine over 18. Okay. Alrighty, and then, to start, I'll just go zoom 6. That'll make us all have the same window. Okay, I don't even see it. And guys, one indicator of why of that I wouldn't see it in this window where the highest Y is 10 is that at 6 a.m. there are already 500 tons. So I need to have a Y values that are at least that high. So let's go like this. So our window. So our x-axis stands for time. So let me just do time from -1 to like 48 hours. And then Y min, so the Y values stand for the amount of gravel, or no, it's a rate. So we can't have negatives for sure, because it's a rate. So negative, and then let me go up to like, I don't know, 500, 550, and see what happens. Okay, great, so there's that. Okay, and that is G of T. Okay, and I'm asked to evaluate G of 5. So let me, in my window, go here, and I'll make my X max like 10. Let's see what that looks like. Okay. All right, now guys, we're gonna do a couple things right in here. So if you wanna find, so this is the graph of G. So if you wanna find G of 5, you can go like this, second, and then trace for calc, and then value. And then I hit 5, and then that is gonna give me G of 5. All right, so this is A. So so you should be doing this along with me. So G of 5 equals 98.141. And what are the units on G, tons per hour? Okay, now we're going to interpret this. And guys, I'll have these in class for you, but so what are we interpreting here? We are interpreting a rate. We're interpreting IROC. So the interpretation has to go like this. At an instant, something changes at an instantaneous rate or rate of, this is a little bit redundant, at a rate of blank. Okay, but you have to fill in the details. Okay, so at an instant, so at t equals 5, so that's 5 hours after the day started. So at 11 a.m., something is changing. So what is the something? The gravel, the amount of gravel at the site. Okay, 11 a.m., the amount of gravel at the site. is changing. So what's happening to it? Is it increasing or decreasing is what we have to decide. And if the rate of change is positive, then it's increasing. So the amount of gravel at the site is increasing at a rate of 98.141 tons per hour. Okay, now we're going to find G prime of 5 and interpret it in context. Okay, so guys, G prime of 5, so we're doing IROC, the derivative of G at 5. And if you're doing that, if you do IROC, you move over 1 in the derivative sequence. So G prime of T is over here. This is going to be the rate of change of the rate of change. So its units are going to be tons per hour, or tons per hour squared. And guys, we could find this from our calculator from the same screen. Go second calc, and for IROC, it's dy dx. That's the derivative 6. Okay, and then we wanted at 5. We still have that x value. Okay, so right there at this point, I need the derivative, not the y value. Boom. Hit enter. Dy dx equals that. Oh, nice. Okay, so that's the derivative. I said nice because it's negative. So we get to see what that would look like. Okay, so G prime of 5 equals negative 24.588 tons per hour squared. Okay, and we've got to interpret that. Now, guys, I know we moved over 1, but we're still interpreting IROC. But the thing that is changing, okay, at an instant, something changes. What the something is always, so when you're interpreting an IROC, the something that is changing is the thing in the column before it. So when we're interpreting this, the something that is changing is G, which is in itself a rate of change. Okay. All right, guys, so try to do this without me, if you can. All right, so at 11 a.m., the amount of gravel at the site, the something is the rate at which the amount of gravel at the site is changing. Right here. The rate, sorry, no, that's not it at all. Wait, the rate in tons per hour at which gravel arrives at a construction site. Wait, that's just the rate at which it arrives. At 11 a.m., the rate at which, okay, sorry. The rate at which, my bad, guys. The rate at which gravel arrives at the construction site. Okay, at 11 a.m., the rate at which gravel arrives at the construction site is itself changing. And how is it changing? It is negative, so it's decreasing. Is decreasing at a rate of 24.588 tons per hour. Okay, notice I didn't say negative because I already said decreasing, so I wouldn't use a negative. All right, guys, that's B. Okay, now C. Let H of T represent the total amount of gravel at the site at any time T. Okay, and then we're going to find H of 0 and H of 5. Okay, so over here, so if you're thinking about the derivative sequence, where does H fall? So H of T is the total amount of gravel at the site at any time. That is tons. That's at the very beginning of our derivative sequence. So H of T is like over here. H of 0. Guys, H of 0 is at the beginning of the workday. That's right at 6 a.m. That is our initial amount of gravel at the site. Okay, so yeah. Okay, so that's, let me move. All right, running out of room. All right, sorry guys. Yeah, just try to, if you're running out of room, try to find some space. But so what we've got to do, guys, is we've got to go backwards. But actually, we have an initial amount that we don't need to, that they just gave to us. So H of 0 equals 500 tons. All right, that was the initial amount that they gave us. Okay. Now find H of 5 and interpret it in context. So guys, if you are doing a derivative sequence, or if you're working like within one, going right, let's just assume we're in the middle, going right in the sequence is IROC, derivative, the derivative. Going left in the sequence, so backwards in the sequence, you need the net change theorem, or just net change. You might just want like the amount of change over a certain interval, or the amount of gravel, like the net difference in gravel from start to finish. You could want that, but the net change theorem will allow you to find the amount of gravel at a certain instant. Okay. Net change would give you the change over an interval, but the net change theorem gives you the amount at an instant. Okay, so what we're doing here is using, for H of 5, we're thinking of that as our, so this is our time interval from 0 to 5 as our time interval. And so this would be the initial time, and then that's the final time within our interval. So H of 5 is equal to H of 0 plus the integral from 0 to 5. When you integrate a rate, you get net change. So how do you get net change? You integrate a rate. So I'm integrating H prime of t dt. Okay, so this is how you set it up with notation, the net change theorem. And but what is H prime of t? H prime of t, all right, so if I took the derivative of H, I would land over here. So H prime of t is g of t, okay? So this is, so H of 0 is 500 plus the integral from 0 to 5, g of t dt. And guys, the good news is we've got this graphed. G of t is graphed in our calculator, and you can do an integral also here. So for the integral, we go second trace and down to 7. Okay, lower limit is 0. That's the left end, the initial end point. And then the upper limit is 5. And whoop, it goes like that. So this is the net change. All right, so there was a net between 0 and 5 hours. If the net change is positive, there's a net gain. So there was a gain in that much tons at the end of that 5-hour interval. But we started with 500. So this is 500 plus 635 plus 305. Mm-hmm. 1135.305 tons. All right, and then it does say to interpret. Okay, interpret H of 5. So Interpreting F. So if we are interpreting at the beginning of a derivative sequence, the interpretation goes like this. At an instant, something equals a certain quantity, or there is a certain amount of something. And so, all right, so we're still 5 hours in. So at 11 a.m., there are this many tons of gravel on site. Okay, so that would be the interpretation.